There we go. All right, everybody. Thank you for joining us for a very special session. This is called the SQL Server Truncated Icosahedron table. I will let the other folks describe, if they feel up to it, where that came from. This is the start of a very special series where instead of a formal presentation, what we've got is a topic, and we've got a couple of some of the best people in the world that are going to lead kind of a back and forth conversation around these various topics. I got Thomas Grohser and Brandon Leach today. This is going to be a lot of fun. If any of you get tingly, getting all nerded out on 500 level geekiness, this is right up your alley. So with that, I'm actually going to stop sharing so that way you can see everybody. And let's have some fun with this because this is going to be amazing. So the topic today is more of an infrastructure perspective versus a DBA perspective. It goes back to SLAs. It goes back to just what the different pieces who manage this data platform have in their brain about expectations on availability. Sometimes it works, sometimes it doesn't. So in this case, this is going to be a rather fun and potentially heated discussion on infrastructure level high availability. In this case, VMware vMotion, Hyper-V Live migration, those sort of VM movement tasks versus a SQL Server high availability architecture. So with that, I'm going to turn this over to you guys.
Okay, yeah. So when I came up with the idea for this thing here is I wanted to have some place where when I don't know how many of you know the yearly conference called 8 kilobyte, where session levels go up from 500 to 8,192 and then above that. Uh, I wanted to have a place where we can start where they finish. So, because over there it's only 1 hour and you have to chew through slides and all this. And there's often then I want to have a place where we can pick a very small part of some topic and discuss a lot of details. And today we're gonna try this because when you look at a solution with VMware, and you have a VM that runs SQL Server, it can fail over between two host machines. That sounds pretty much the same as if you have a Windows failover cluster with SQL Server installed on it that fails over between two systems. Yeah? So often in my career, I had to explain to higher ups in the companies I worked for, why are we not doing it this way or why are not we doing this the other way? And today we'll try to go through the things that actually differentiate these two scenarios. So when do you want to use a VM and when do you want to use a complex failover cluster thing? And at the end, we might come to the conclusion there's a perfect system for everything, or the usual standard answer that goes all the way for SQL Server. It depends. And so basically, when you look at the whole thing from 100,000 feet view on top, yeah, you have on the VMware solution side, you have hosts. They run something magically, and you have VMs that run on these hosts. And if something happens to one of the hosts, one of the other hosts takes over and continues your workload over there. And with failover clustering, you have a bunch of Windows machines that form a cluster where you can install a virtual form of SQL Server that runs on one of them. And if that one fails, one of the others takes over and keeps on running. So from that point of view, these two solutions look identical, but they are not the least. In my opinion, they have nothing in common except that they run on physical hardware at the bottom. And they both need some form of shared storage solution, yeah, to work. And I have a few notes on my end, which I want to go thing is, and then have a discussion about what this is. It's really hard to start somewhere. So the first thing I want to start is to look at possible deployment scenarios. So what can you use either one of the solutions for? Easy. What can you push it to barely make it? And what the solution cannot do. And with that, I mean, can I use it for high availability, meaning they're both, all the nodes are in the same data center? Can I use it for high availability when I have two data centers in the same town and they are fairly close? Can I still use the solution? Or is it also usable for disaster recovery where where some of the nodes are hundreds of miles away? Yeah. So this is the thing is, and maybe we together can figure out what's the maximum distance is you can put your nodes apart in each one of the solutions. Yeah.
I could throw out a scenario for you
Yeah.
to help get us started.
Sure.
Let's assume a company is looking to implement HADR for the first time. They want both. They've got a data center currently in, say, Milwaukee, and they've got another data center in Ashburn, Virginia. Given the fact that you've talked about a few different technologies, VM, HA, FCIs, failover cluster instances, and availability groups. What are the pros and cons of each of those?
Yeah. So I want to limit it today to just talk about
Okay.
vMotion and FCI because availability groups is a completely different beast, and we have to figure out one of them first. So I'm
Yep.
saying yes, FCIs are availability groups are sometimes exactly what you would need to overcome one of the shortcomings of either one of them. But
Yep.
let's
Okay. So let's
something
change
for
the
next month.
scenario. A single data center,
Yeah,
right? You have single data center and you need to
it starts
minimize
with that.
downtime.
Yeah, yeah. So
How, so do you want me to talk about VMware a little bit?
yes, please.
All right. So most people here are probably familiar with VMware. You have a hypervisor or a cluster of hypervisors on which you run one or more VMs. The idea behind HA in VMware is that if a node in that cluster goes down, the other nodes can bring the VMs online. Now, this comes in two flavors. There's the vMotion, and then there's v storage motion, right? Moving the actual disks, the actual storage, etc.
There's a
This
third
has
piece, and that would be the act of the restart if a host goes down, like you
yes,
said. Yeah,
yeah. Sorry, I did miss that one. I don't use that one very often.
that's a good thing.
And so when you do a vMotion, hopefully there's kind of a dedicated network for it. Uh, vMotions to move a VM from one node to another can be pretty heavy. You want that to be run as fast as possible. What's actually happening underneath the hood is the cluster starts to get things ready across both nodes. Then it enters a migration phase where it starts copying over data, both virtual disks, memory, uh, getting them ready to come up on that other node. And your system or your original VM is still up during all of this, but it can receive a performance penalty as a result, especially if you've got like a highly active SQL Server, right? You're probably going to notice that impact.
Yeah. What
So,
the reason for that impact for everybody on here is what it's doing. It does a pass where it copies the contents of RAM as fast as it can possibly do it. And then it doubles back and it's like, okay, what has changed? And then it does it again. And then it does it
And
again. And
again,
then it does it again. And when it gets down to a delta of 0, then it flips a switch and now the VM is running on the other machine. If the memory churn inside that virtual machine is so significant that it literally can't keep up, here's where the performance penalty really comes from. It essentially grabs a wiffle bat and starts beating the virtual machine. It's like, slow down, slow down, slow down. And I'm being non-technical here because I think it's funny, but it's basically what it's doing. It's called a stun operation, where it tries to slow the VM down to cut down the amount of memory churn so that it can get that delta over to the other machine so that it can flip the bits and move everything over.
yep.
So as the
The
non-VMware
Go ahead.
expert, what I'm seeing is what you're telling me, VMware can move the workload from one machine to the other without ever stopping it.
Correct.
It's as me as the client, if I talk to SQL Server that is in that VM, I will not notice any
You
downtime.
shouldn't notice.
Yeah,
There is VMware will tell you that there is a brief, very, very brief as it flips.
yeah. And that's perfectly fine. So like when I would ping the machine, it would drop a single ping or something.
Yeah.
Yeah,
Usually
The
it's
risk,
treated like a TCP retry, so it's pretty
yeah.
transparent.
Yeah. So,
the
and from my experience when working using these systems, I never saw during these live migrations, I never saw um, an outage that the client noticed. So it's
the
all handled on the network layer that, okay, a packet got lost, let's do a retry or something. Yeah, these are normal retries that you see all the time because you would be surprised how many network packets during a day get lost somewhere. And that's just one of them. Yeah. So yeah, that's a point for the VMware solution so that you can move this thing for maintenance reasons or load balancing reasons. Any reason you can have, you can move these machines around in as many times as you want.
one thing I
And
would caution, TG, is that people should understand their workloads, right?
yeah,
And the sensitivity of those workloads to latency.
yeah,
Um, for example, as I said before, if you've got a highly transactional system, the vMotion is going to slow that system
yeah,
down by however it needs to
mhm,
catch up.
yeah,
And so we as DBAs, we understand the characteristics of our workloads. So we might want to limit when we do a vMotion. Maybe there's a couple hours in the day where we want to try to avoid it.
yeah. But it would let me do something like, let's say I have 3 or 4 VMs on this cluster,
Yep.
and one is the busy one that you told me. So during the day when this thing is super busy, I it's the only VM on that machine, but overnight when it's not that busy, I can move some other machines there to use that CPU power. So and my clients would never notice it. So me as a DBA or whoever administered that, I could move stuff around in a reasonable manner, not going crazy and moving
Yes.
it all day long. Yeah, but I could move it around if I needed, without causing massive downtimes. I don't need to inform people all the time. It lets me super manage things, and this works great when everything is in one data center. Makes sense because I understand we need a lot of bandwidth to move that memory around, and I'm pretty sure there's some limits how much memory you can have. Um, but
It, from
usually
my
these,
from my experience, usually if you are having a problem due to vMotion, chances are your vMotion traffic is running across a network with other stuff.
Or that the network is just not sufficiently
Yeah.
speedy or configured to actually handle the kind of volume that you're trying to send. Now,
Mhm.
note for everybody in the call, everything we're talking about right now is a proactive operation.
Yeah,
Everything's perfectly fine, nothing is down, and you need to move it, either load balancing or
mhm,
maintenance or those sort of
yeah,
tasks. So
yeah,
that's item number one to put in the back of your mind.
yeah. So let me quickly compare that to the failover cluster thing. Failover cluster does not have that. Failover clustering works that SQL is running on one machine. and it's ready to run on the second machine in the cluster, or the third or the fourth, how many machines you have in there. And at any point in time, you can say fail over, but the name says fail. So what SQL Server is going to do is shuts down on one machine, moves over to the other machine, and then comes back up. So you will have an outage. How long is this outage going to be? It depends. So I've worked with failover clustering since SQL 6.5. I've used it a lot, and failover times are between a few seconds and several days. Uh, if you pick the wrong moment. So with failover clustering, you always have to be super careful to and you look at what's going on the machine. So for example, if you think, hey, since it's an outage, I fail over during my maintenance window, and you don't wait for the 3-day index rebuild to finish, and you fail over after 2.9 days before the index rebuild finishes, you will have the rollback of 3 days before the system is ready on the other side. So you have to be very careful there.
That sounds like
Um,
you deserve a Purple Heart for things that you've seen.
it's, I'm just old. You can see this from the hair color.
No, we call
And
it seasoned.
yeah, it's fine. But so FCIs is always stop and start on the other side. So there's no live migration form in FCIs. Yeah? So that's clearly thing is. The nice thing is that on the FCI side, a planned failover and an unplanned failover are pretty much the same. With one funny detail that I've noticed over the years, an unplanned failover is much faster than a planned failover. Because if the node actually dies, you don't have to wait for the shutdown to happen. Because believe it or not, sometimes it can take forever for SQL to shut down. The coming up on the other side might be really quick. I've seen sometimes, especially because when SQL shuts down, it tries to do one last checkpoint. And if you have a lot of memory, that takes a while. That can be minutes before it has completed this checkpoint. And during that period, it doesn't accept any new requests. So it basically says, I'm going offline, and now I write all down everything I have in memory. I write it down to disk. Once I'm done, I verify that the disks are happy, and then I fail over. So if you have a crash, the other side notices and takes over and just starts the whole thing, and you save all the shutdown period. So in FCIs, the failover plan takes much more time than unplanned, which is, in my opinion, so when you have to have a good solution for maintenance and you need to rearrange your workloads a lot, FCI doesn't sound to me like it's what you should use as the primary choice. But we might have other reasons why you have. So summary of that thing is for planned maintenance, it looks like VMware is kind of the winner here in this thing. It
The,
doesn't mean it's the overall winner. We'll see. But this is something for me. So
there's also one more point just for you,
yeah.
TP. Sorry to interrupt. Um, in regards to when a failover cluster instance goes offline, there is one more difference. When you do a planned failover, you're generally telling it what node it should go to, unless you do best possible. So it doesn't have to go through that full quorum arbitration process.
Yeah.
That being said, that shutdown is really what you're right. It sucks up all the time.
Yeah. The other piece here to note is that this is talking about platform maintenance, not necessarily operating system level maintenance.
Mm-hmm. Yeah. Yeah. So thing is okay. So within one data center, vMotion sounds like great. What if I have the data centers? I have two data centers, but I call it in the same town, but they are my translation is the distance between is less than a millisecond of network delay. Yeah. So it's basically the same as in the same data center, but they're on the different ends of town. But we're not talking about network latency becomes unbearable. You can manage that with good fiber cables, pretty good. Can you still have a MVM cluster that spans the two data centers within the same town? If How would you handle the storage? Would the storage be in one of the data centers, or is there a way to have the storage in both data centers?
Depends on the latency between them. VMware says you can do a spanned data center set like that if the latency is less than about 10 milliseconds. And that's for vMotion storage connectivity. I don't know if I would want to put storage on one building connected to machines on another building. I actually have a running joke about that from one customer engagement.
Okay.
I always said, why does
But
storage cross the road?
it's possible to move it in both data centers.
Yep.
There's a solution. Okay, good. FCIs, same thing. Out of the box, when you buy Windows, you can have the shared storage on some fiber channel storage array. But it also lets you use a built-in replication in Windows where you can use Windows disk replication services to replicate the data to another data center. That is, I've done it once. If anybody's interested, it's about a 60-page instruction manual how to do that, with screenshots and everything. So it's fine. It was the only way to get a replication distributor into HA, because at the time, only the only high availability technique that the distributor could do was failover clustering. So what was the only solution to get it in another one. We had it at 27 milliseconds network delay, the other data center, which was about 800 miles away. Yeah, which is like atomic bomb blast radius still questionable, but usually safe enough that the same wave would not hit both data centers, and one were more inland and the other one was on the outside. So it is possible to do that. And there is solutions from storage vendors that let you replicate the storage to the other side. Yeah. My problem with both replication scenarios are they work great when you have planned failovers, like for maintenance reasons or something. They work great when you test it. They usually don't work when you have an actual outage. And the reason for that is that outages are never clean and nice. Outages are always happening in waves, and even if the wavelengths are very short, but the best storage array has every storage array that is anywhere in like a reasonable size has more than one power supply. And not they can't run off that one power supply. So the problem is that parts of the storage array shut down earlier than other parts. And now it really depends in which order they die, depends on which data makes it to the other side. And this becomes a problem. I had several cases where the customer was actually agreeing to test power outage by hitting the breakers manually, which is even the power switch on the thing works different than when you hit breakers. Especially these arrays are connected to multiple circuits that are on different breakers, so you're not shutting down everything at the same time. That was the thing is, and every time we randomly put them, and half the time the data on the other side was no longer usable for SQL Server. The problem with that is that SQL Server needs the write order persisted. So if you write to this disk first and then to this disk, SQL needs the IOs to finish in that order. And if you replicate it to the other side, it has to do it in the same thing. Just imagine you write to the transaction log and to the data disk. The transaction log has to finish first. If you randomly, to some problem, you have a checkpoint running and you write the data thing first and then the transaction log later, on the secondary side, because they replicated it in the different order, you are in massive trouble. Yeah. Also, some of the arrays, what I've noticed is they don't copy the data in the same chunk size as SQL Server writes. Yeah. So one of the famous storage array vendors that should not be named, but is very tied to a German physicist that tried to figure out how the universe works. They write 768 kilobytes in one go. That's the chunk size that they move across when they have to replicate data across data centers. So when you do a 60 kilobyte IO on the log write, it actually copies 768, which is 3/4 of a megabyte, but don't know why they chose it, every time. So the same happens if you write an 8 kilobyte page. They write the whole thing. So if this now doesn't happen in the same order because SQL already wrote another page somewhere else, this might accidentally get copied over before the transaction log write finishes. So this is the problem why when you do it clean in a test, it always works because they all synchronize and are happy. Some of these storage arrays have modes where you can put them in like, you can group the disks in a protection group where they actually preserve the right order. The problem is then everything becomes a super synchronous thing. So they have every IO is a synchronous wait on the other side, which 27 milliseconds from one data center to the other, that means every write takes 27 milliseconds. That's today, that's like an infinite amount of time. That takes way too long. I mean, 27 milliseconds should be a couple of thousand IOs these days. Yeah? Um, and so this is what you have to be careful. And I've never done the testing with VMware, but I could guess if VMware relies on storage array replication, similar things could happen. Yeah. I know the thing is the Microsoft replication service had the same issue. The way we could fix it in that case that I had was we only used a single disk. We had a single disk that got replicated to another single disk on the other side. Yeah, it was physically one disk. There wasn't even like some stitched together disks or a logical disk or something. It was one disk here, one disk there. A write happens here, the write happens on the other side. So there could not be any I'm doing it faster, I'm doing something ahead or something. That made it work, but it also limits you to how much you can do. Yeah. So um my thing is, while technically it's possible to have a failover cluster between two data centers, I would never do this today. 10, 15 years ago, when there was no alternatives, it I had to do it. Yeah. Today, there's plenty of other ways that we will not discuss today. It's going across data centers is not something you should do. And if you do, find people like me, David, Brandon, and try to get them to help you because one little mouse click at some check mark somewhere can make the difference between it works and doesn't work. And again, nobody's actually testing this. It's very different, and you have to believe me here because I cannot prove it, but an unplanned data center failover from one data center to the other is very different than anything anybody ever came up in a DR test. I even had companies that were willing for the DR test to like unplug the network. it's still not the same because you're unplugging everything at the same time because there's one line between the data centers, so everything stops working in the exact same moment. The problem is if it's not in the exact same moment. So even if you have like water running through your data center, it will kill something on the left side before it will kill something on the right side. And most storage arrays take up a lot of space. So they will not die in the same thing. And each one of the cabinets they are in has different power supplies. So the power will not go out in the exact same moment. Yeah. And even if the breakers fail at the same time, one capacitor and one power supply might have 3 milliseconds more of load than the other one. And in 3 milliseconds, a log write can be shipped over that should not be, or a data write can be shipped over that could not be, and something can go wrong. Yeah. So for me, for a long distance deployment, FCIs are technically possible. Would I ever do it? No.
To piggyback on something you said a moment ago, all of the major hypervisors are subject to this. An example of this is in VMware, but not just exclusive to VMware. If a storage connection gets cut, but the hypervisor is still up, it will attempt to cache IOs poorly, and even worse things happen.
Yeah.
No, it's
The law
yeah,
of unintended consequences.
Yeah.
yeah. No, it's these are basic rules that Microsoft published in SQL 4.21.
Yep.
You have to preserve the write orders, and the arrays must follow when SQL Server requests a pass-through write, which is basically the log write. The array cannot commit it before it's not guaranteed to be durable. Yeah. So if and caching is never durable. Yeah. Yeah. I mean, there are caching solutions out there which have battery, buffered memory, and all these kinds. They work. Yeah. And I've tested this. So we had a RAID controller with a battery-backed memory cache module on it, which allowed you to, when your server failed, take out the memory module with the battery and carry them over to the other machine and plug it in, and then start up the other machine and finish your log writes. Yeah. Again, great idea in the lab. It's awesome. Would I ever use this in production? No. uh, because you're going to need a couple of ambulances carrying out all the system administrators that had a heart attack doing this at 3 a.m. in the morning, because that's not something you do a lot. Again, does it work in theory? Yes. What I think is storage array on the other side have these capabilities built in. So they have their batteries, and when they come up again, they know how to read out all these battery-backed caches and all this. That's fine. And with that, I never had a problem in the real life when we tested slash tortured these devices. Thing is, with the battery-backed RAID controllers, we had the problems, but we also decided that the problems were always human mistakes, because when this system comes up, it asks you a lot of questions that are formulated like don't delete, not do not delete the data, yes, no. And then you have to read this, and again, it's at 9, 10 a.m. in the morning after a good night's rest, everything works fine. 3 a.m. in the morning, you just got woken up, you might read that question wrong. Yeah. And there is no second try. You cannot start over. This is a one-time thing only. Yeah. So yeah, that's the thing is. So both solutions are basically, if I try to summarize the concept, what we talked here, both solutions are more like a local high availability with the possibility of when we talk in cloud terms, you can put it in two availability zones, but you cannot put it in two regions. It's
I
it's
I like to think of it, TG, as you with FCIs and vMotion and VMware HA, you get HA, high availability.
yeah,
You can hack DR out of that, but it's
that's good. Yeah.
generally a bad idea.
Mhm. Yeah. That sounds thing is, yeah. So good. Okay, so both solutions, let's keep them in one data center for professional solutions and leave the DR part to experiments and last resort solutions if nothing else is available. Yeah. One thing during my career I often had when I had to implement these HADR solutions that I had to be very careful what else I need besides my actual cluster that runs the stuff. Yeah. Because in FCIs, if I have my two machines, that's in theory good, but I need one tiebreaker in case these two can't figure out who should run the whole thing. Two people are discussing something and they can't come to a solution. The same thing for two cluster nodes. They try to communicate and they can't talk to each other or whatever the reason is, you need something else. Yeah. So on the FCI side, there are lots of solutions for that over the years. It all started with a quorum disk. This is back in the days when a cluster could only have two nodes, or even with more nodes. Thing is, it's basically one disk that is between the two machines. That is basically says if the two machines can't see each other, whoever has that disk right now is the new winner, and that's the one that will bring it up. The drawback of that is that might be the wrong guy. Because if you have the quorum disk in the data center that lost network connectivity, it will start up there. And in the other data center where you still have network connectivity, the system will shut down or take SQL offline. Yeah. So the quorum disk is not the ideal thing to hang is. Another one is I saw a lot of people that always kept the quorum device on the other machine, the passive node, to balance the load a little bit. So every time there was a network blip, you had a failover because it decided you have to move to the other side. Yeah, it's the little things and this is why I want this thing here. This is
Yep.
where we can discuss the little things that will happen. Yeah.
Well,
Um,
the way I look at it, when a 1 in a million edge case is something you see multiple times in a week, it's
yeah,
no longer a 1 in a million edge case. And
yeah,
these are the things that nobody thinks about until you
yeah,
encounter it.
Yep.
yeah.
The
And what,
the thing about clusters in general is you have to be very careful about how you design them. Things like quorum and the network, if you get those wrong, nothing works, especially not the way you expect. For example, I recently ran into a cluster where they had misconfigured the network interfaces. They put in the wrong subnet mask. And let me tell you, that creates some rather interesting issues. Yeah, I mean it was easy once we knew what to look for to identify it, but it still took us several hours to figure out, and it required downtime to fix. For example, roles within that cluster that should have just been able to stay running because the interfaces were misconfigured went down. So things that were previously safe to do, non-destructive changes, became destructive changes.
yeah, no, it's saying so for the quorum after the disk, which today should not be used anymore, but sometimes it's the only thing you have. The next option is to add a witness, a third node, which can be a third active node that can be used in the cluster or can just be what is called a file share witness, which is basically a file share on any machine that speaks SMB. I highly recommend it also be a Windows machine because I've seen a lot of excess issues on SMB shares that were reverse engineered on some Penguin-based software. And this is way better than the disk, way better than the disk quorum. The problem is it needs to be placed somewhere where it makes sense. Yeah. The disk was easy. It's between the two machines. Yeah, there was no option. For the file share, it's the problem is if you somehow have a separation between the two nodes, you can't put it with either one of them. So even if you put them in two different cabinets, the file share witness needs to be in a third cabinet. Because otherwise, the one guy that doesn't have the file share in its cabinet has basically no chance in case of a power outage. Because if you put them in one cabinet and the power gets lost there, you lose the witness, the file share witness, and your active node at the same time. And the other side says, oh, I can't see both of them, so they must be fine, but I'm the one in trouble. It's the same as with the quorum disk when it was on the wrong side. You could have the same problem here. So, but it's much easier to put that in a third place. Yeah. And my recommendation was always put it as far away as possible. So that this is not thing is, yeah. And often I give clients the thing is, yeah, have your two nodes, your two active nodes that are running the workloads in your data centers, and put the witness in a file cabinet in your office. Yeah, because then even whatever parts of your data center loses power, your office cabinet is still running fine. Yeah. Or in the latest iteration, and that's if you can do it, is Microsoft offers a service in the cloud that basically that file share is a magic device in the cloud that doesn't even look like a file share anymore. You just basically give it the address in the cloud and the cluster does everything there. It's insanely expensive. It's about 10 cents per year that they will charge you for it, or taking, no, sorry, 12 cents per year. The actual cost is a fraction of a fraction of a fraction of a cent, but they are nasty and they're rounded up to 1 cent per month. Um, so if you have 1,000, it costs you $10. If you have 1,000 clusters, it costs you $10 a month. It's probably the cheapest cloud service I've ever seen. And it takes the problem away that it's somewhere near your devices. So even if you have a stretched cluster across data centers or something, this will still be somewhere else. Yeah? But again, you have the problem is, in this case, I've seen, yep, this thing was in the internet, and the internet was reachable from data center A. And if data center B needed the internet, it asked data center A to route the traffic to data center B. In that case, it doesn't work. So that only works if each one of the data centers has independent access to the cloud or the internet, as we called it before. So the problem with the witness on the FCI side is you have to get it right. Otherwise, this thing is not going to do what you expect it to do in case of a failure. It will still work while everything's fine. If you lose your witness all day long, your cluster is not changing. That the failure of the witness never causes a shutdown of the cluster. This is not what's going to happen, yeah? Because you always need more than 50% of the cluster to run. And if you have two nodes plus the witness, each one is 33.333%. So if any one of them fails, the other two just keep on running. Yeah. But if it's in the wrong place, the whole thing will not do what you think it's going to do. And you have to think it through. And a lot of people only think about, oh, if that server fails or if that server fails, how it's going to behave. Yeah, but you also have to think about it. What happens if the switch behind it? What happens if the router? What happens if the data center loses power? All these steps, because if you don't think through all these individual steps, which can fail, and usually with a two data center, two node cluster, there's about 27 different ways this thing can die. That also depends in which order they die. Yeah, because the real problem starts when you have more than one thing fail. Yeah, because in a two node cluster with a witness, if one fails, everything's fine. But what happens if two of them fail? Yeah, not from the beginning, but about a decade ago, Microsoft finally realized that this is a problem, that if you have more than one device failing, and it's a possibility, they implemented something they call dynamic quorum. So if you first have three people that vote and one of them disappears, they reconfigure the system internally till this thing comes back up, that there's a better chance for the other two to survive. Not in all cases. Sometimes you have to help it
So
because the problem is with three, it usually works out correctly. The problem is if you have three active nodes, four active nodes, five active nodes, then it gets a little bit tricky because the chance that more than one dies at a point in time is easy. So let's again take the thing is I have a four node cluster. Two nodes are in one cabinet and two nodes are in the other cabinet. Very common scenario. Yeah. Not as common as many other things, but four node clusters are common. Um, so what happens if one of these cabinets fails? I suddenly have two participants less. I still have my witness, that's fine, but now the other side can still be running. But just imagine you have only three, which is also a very common scenario that you have like two nodes that are right next to each other. So high availability is super easy because everything's connected through one switch and super fast. And you have one at the other end of town, yeah, which still fine, but it's a couple of microseconds farther away, maybe a millisecond. Yeah, still good enough for everything we need. But now what happens? You don't need a witness in this case because you have three nodes, but you still need one because this is the problem is you have three nodes and with the three nodes, what happens if the two that are in the same availability zone in the same cabinet, if they fail at the same time, then suddenly out of four voting parts, two are gone, and the other two are not more than 50% anymore. So suddenly nothing runs anymore. And that took me a long time to figure out. And I actually didn't figure it out. Mike Steinecke, he works now for Microsoft. Back in the days, he was still on the other side of uh, on the light side of the darkness. Um, and we spent about 3 or 4 days to go through all the scenarios, what can go wrong. And we found out the only way to make this actually work in all cases, and doesn't matter which one dies in which order, is you can take away the vote from machines so that they are part of the cluster, but they don't count when it comes to high availability. They have no vote. Their job is to sit there and work and do something, but when it comes to figuring out who should run, they recuse themselves. And it's like, oh no, I have a conflict. I can't take this. Yeah. And the strangest part is what you have to actually do is make the normally primary that runs your workload, the machine that is the active one, that one cannot have a vote. Then you still, when you have three, yeah, then you still have a witness because you only have two that can vote. So you need the witness again. And then it works regardless in which order and how many at the same time die. It's
so
counter what you would, nobody would ever, based on a gut feeling, say that's the one that I have to take out of the whole scenario to make it work. But it's the only one that works. And if you draw it down off a sheet of paper and cross them out in all things, and this even works with network connections are failing, cabinets are failing, so two of them die, the same whole data center fails. The only scenario where it doesn't work is if everything dies at the same time. So you have all the machines are in the same town and the town gets swallowed by some earthquake. Yeah. Sorry, it's time
so
for DR.
TG, my apologies. My internet failed over while we were sitting in
Yep.
here. It does that about once a week. So yeah, the ISPs in this area are terrible. But
Yep. No.
did you touch on dynamic quorum?
Yes. That was
Okay,
the
good.
rant was about. Yeah.
Because that can get you into a little trouble here or
Yeah.
there in the wrong
So
scenario.
let's circle back to the VMware solution, how does VMware figure out where to run stuff?
It's a very simple algorithm based on essentially CPU and memory consumption on a per host basis in a cluster. So if a host were to fail, or you're just powering on a new virtual machine, it's off, you want to turn it on. It essentially looks to say which host has the least amount of demand, be it CPU or RAM, and then it will just look to see, does the VM quote fit with its memory footprint here? And if so, it turns it back on there.
So let's say I have 3 machines, 3 hosts, 2 of them run workload and one of them fails. Pretty much everything will move to the machine that didn't run anything before.
Yep. Yeah, what VMware
Or
would
if I
do is
have
it
two
would,
of them running to 50% and one 100, and the one with 100 fails, half will go to the one and half will go to the other.
in theory, yeah, yeah.
Yeah.
And essentially the VMs are down, host is dead, the VMs get mapped to the new or the other machines on the cluster
Mhm.
and they get powered on within about
Yeah.
anywhere from 30 seconds to a minute.
Mhm.
Yeah.
Yeah.
Generally, VMware will try to prevent one host from being 100% utilized. It'll try to balance that workload through the process of vMotion.
Mhm.
Yeah, and if it can't, there are pieces of it with the load balancer built into it where if it needs to move other VMs to make room for this other one, it can
Mhm.
actually do that, which is arguably pretty slick.
Does it need vCenter, this management software, for it
It
to
it
do
does
that?
need
Or
vCenter to do that, yeah.
yeah, so that's kind of the witness or tiebreaker or the chief or
It's the
some
orchestrator. It's the
the
brain
orchestra.
behind the automation.
And can I have that vCenter thing like highly available? So
In theory, yeah. I'll just leave it at that.
I mean, I would
okay.
generally recommend putting the vCenter database itself outside of the cluster so that you have access to it should you have a catastrophe.
Yeah.
Um, but what a lot of VM admins I've seen do is they create a VM within the same cluster and then they have their database there, and then when they get into a bind, what they thought was HA turns out to not be HA.
What
Uh,
they have today, the right approach, in my opinion, is you have a separate VM host cluster just for administrative devices like this. You have different storage. You have a couple of vCenter appliances, which are self-contained, but you can treat them in a highly available set. And you just say, uh, appliance A will be on this set of hosts on this storage. Appliance B will be on a different set of hosts on different, totally isolated, totally disparate, separate storage. You do it that way. That's about as good as you can get with it.
yeah. And so I had the same case with the VMware database that it was on the cluster that vCenter was managing. And
Oh,
yeah, it was great. It took a while to get that thing up and running again. But the more funny part is, in one company I once worked, they had a very specific way of dealing with DNS. And
Oh,
what nobody knew is that DNS also needed a SQL Server database in the background.
oh no.
And when we had the first real DR scenario where we were not having a test where the administrator knew that this had to happen, we had the failover to the DR side. And on the DR side, nothing could come up because for SQL to make clients run again, it needed to change the DNS. For the DNS change to happen, it needed a SQL database that was running on one of the SQL servers.
Uh,
So that created about a 2-hour outage till someone was driving to the data center, getting into the machine, changing the IP address manually, and then everything came up again. Yeah.
so
It was
this
fixed.
this reminds me, TJ, of that situation where the DNS servers were behind load balancers.
Oh yeah. Whoever is listening, yes, you can put DNS server behind load balancers if you have read-only demand. So if all you're running is web servers and email clients and your favorite social network apps and whatever, it works great. If you have any form of clusters that do failovers between different networks, these things need to dynamically change DNS. And if you have a load balancer, the problem is that DNS change is a two-step process. So what happens is step one goes against one DNS server, and then the load balancer switches you over to the next one, and step two goes to the other DNS server. Both of them look at it and say, that doesn't sound right, and discard the changes. And yeah, let's not say, but that took several weeks to figure it out.
Yep.
Uh, because nobody knew about that change. Someone changed that. Everything was working fine. And one day to the other, failovers were a random process. It works or not. And if you click retry it, it just works normally. But it is, yeah. So whenever you do anything in clustering, and I think, correct me if I'm wrong, doesn't matter if it's VMware thing, everything around it needs to be in a very basic and simple configuration. Yeah.
Yes.
The
Yes.
more magic stuff you install, the more likely it is this is not tested with clustering.
Correct.
Because I don't know the actual numbers, but my guess is that way less than 1% of all machines are in some form of a cluster. It might be because even in VMware, for each host that is in a cluster, we're usually talking several dozen VMs that run on that machine. Yeah. So even there, it's a small percentage of machines that actually run in the cluster. Everything else runs in its own VMs. And it's the same with Windows-based failover clustering. This is a very rare breed. Yeah. You have hundreds of web servers and application servers, and then you might have a dozen of SQL servers somewhere that are running on clusters. Yeah. That means that whoever manages these things has a fraction of the experience for how to deal with a cluster than with all the other ones.
There's
And
another aspect, TJ, and
yeah,
that's a lot of that knowledge that sysadmins are getting. Like they're being told things like putting DNS behind load balancers is a best practice, but they don't realize, like you said, it's a best practice just for read only.
yeah. If you're a big web hoster, that's the perfect solution, and you should do that. Yeah. And you can use the same DNS. You just pick two of them and use them for your clusters that are behind the load balancer. It's just fine. Yeah. These two have like 1 or 2% more load, and that's it. Yeah, and that should not make them sweat in any form, size, or shape. Yeah, you can run a lot of. When I was still working for an ISP, we had thousands of customers that were running against this, a pair of DNS servers. Yeah, it's not a big deal. Yeah.
Yep.
So yeah, so now we're getting somewhere. So the what I want to convey to people is whichever form of clustering you have, you need someone that understands that. So it's if you are the DBA and you have to work with a sysadmin or a VMware admin, they need to understand their side, the Windows and the OS part or the VMware part, how to do that correctly. Because if this thing is not working the way it should work, there's no chance that the SQL that runs either in the VM or on that cluster will ever behave the way you're expecting it. Yeah, it's whenever you use clustering in any form with SQL Server, and that is with failover clustering or with availability groups, yeah, 99% of the problems are in the underlying cluster. Yeah, seems to be from an experience that it's easier with VMware, but still, um, you have to discuss with the whoever runs VMware in your environment to make sure that these little gotchas are not forgotten.
Yeah, the hypervisor allows you to do normal networking changes
Yeah.
quicker. I'm not going to say better. I'm not going to
Mhm.
say less incidents. An example of this at a group that we worked with just last week, they had a short outage. A group was making some changes to software-defined networking and decided that they wanted to swing the bunch of servers from one device to another all through software. Should have been instantaneous. No, 11 Windows Server failover clusters. All of them had errors in the error log. 6 of them failed over to the point where roles would not come back online. Not the most fun.
No.
Good. So the next thing that when you look closer at these two solutions is on the VMware side, what I see is you have one virtual machine that runs one instance of the operating system, and then SQL runs in that instance of the operating system. When you fail over, you're running the same instance of Windows and you're running the same instance of SQL Server. There's no change. Since it even fails over planned without even stopping, it has to be the same. It's not like, oh, go there. No, it's the same that moves over. On the FCI side, you have two independent installations of the operating system, where you then run the clustering on top of it, and then SQL installs on both machines, on one machine fully and on the other machine partially. And when it fails over, the full thing plus the partial that's on the other side becomes one full thing again. So you have two operating systems and you move your SQL XE from one to the other. And that's also a place where I've seen over the years a lot of things that went wrong. Yeah, because whatever has to be configured on the OS level has to be done on both sides.
Yep.
Because
Patching.
encryption certificates,
Mhm.
storage certificates, network certificates, all kinds of encryption passwords, users,
Network
local
settings,
users, file
firmware.
shares. Everything has to be done on both sides because or third-party software. Not once I've seen, hey, we installed a new backup solution and then you have a failover and there's no more backup solution on the other side because nobody installed that. Or the other problem that you can have is that you install something there that is not cluster aware, and then you get every day a failure report that half of your machines report that they couldn't do backups because they were the passive node that didn't have any databases on them. Yeah. So this is the part where, in my opinion, VMware wins like with 1,000 points ahead of the Windows solution, because if there's one thing guaranteed is if you have to do something twice, you will most likely do it only once. And no, just imagine you have to install like 10 clusters. That means you have at least 20 nodes. Yeah. You have to do the same thing 20 times. This will not work. It doesn't matter how good your checklist is. At some point, somewhere in the middle of doing something, someone will disturb you. You will get distracted and you will skip a step or do a step twice or do it with the wrong values or the wrong certificate or something. Yeah. And this is not something, it's not easy to test because you're coming back and it works, but it only works on Mondays and not on Tuesdays or something. Or it works while the backup solution runs on a specific machine. But if they also fail over, so now you have four scenarios that you have to run. It only works in this scenario, but not in that. So it works this way, but if this machine falls over, it doesn't work in either one or just in the bottom one or something. It's the thing is, and Microsoft's not making it any easier. I'm just saying like TLS, these encryption settings in Windows that suddenly have to be at a certain level. I've seen many places, yep, the active node, yeah, we changed it, everything works fine. The weekend comes and the maintenance failover happens, and suddenly nobody can connect anymore because, of course, nobody did it on the passive node. So having this in one VM makes this a lot of. On the other side, if you have two independent things, if your Windows installation dies for whatever reason, the FCI can fail over to the other side and maybe keep on running there. That's a theoretical thing. I've never seen that. Yeah. If for any reason the OS was destroyed, it was usually done through some magic rollout of some patch, and that usually did the job on each and one of the nodes. It's very rarely that they only screw up one and not screw up the other one, because it's usually after patching that something doesn't work the way it's supposed
Yeah.
to be anymore.
Usually they stick both nodes of a cluster in the same patch ring.
That too, yeah. It's also something, never reboot both nodes at the same time. That's also very good learning. The bad thing is this sounds also simple, but
It's
if you
not.
work in a larger organization, you have no control when that happens.
Right. And at a micro level, it's easier to control. But let's say you have 500 of these machines. The
Yeah,
odds that you're going to slip up
yeah,
or that human error is going to do any of these things, it's significant.
yeah.
Well, the
Well,
more complex an environment and process you have, the more opportunity there is for something to go wrong, a mistake to be made. So you actually increase the odds of a mistake, right?
Yeah. And the blast radius from these machines is not insignificant.
yeah. And sometimes it might just be that you outscale whatever solution you built that worked. Simple example, you have 20,000 machines. Okay, they're all clusters. So 10,000 primary nodes, 10,000 secondary nodes. Great. We put the 10,000 nodes that are primary in the first patching window at 9 a.m. and we put the other 10,000 in the second patching window. Everything works fine. The first one takes 58 minutes to patch everything. Everything's ready. And then the secondary starts patching and takes another 58 minutes, and everybody's happy at the end of the day. Now someone buys a bunch of new machines, and instead of 58 minutes, it now takes 61 minutes. And
Game
the
over.
primary side is still rebooting, and the secondary side starts rebooting as well. And suddenly, all hell breaks loose. Yeah. This is just sometimes you just outscale a solution that worked just fine. I had that with backups. It was great. I had a backup solution that went through all the machines and took backups. And suddenly this took 25 hours every day. And everybody was wondering while everything was collapsing, because at some point I could not. It might be even faster when you do it with log backups, that you have to do like every 15 minutes, and suddenly it takes 16 minutes to go around and collect them all. Yeah. Um, so this is there's the thing. Good. Uh, the next thing I have in my cheat sheet here, I only have like headlines. What we should talk about and not forget is what can trigger a failover or a failure for these things to do an actual AJ moment. Yeah.
With that, I do have the whole rest of the week or the day and the week if we need that.
It's a long list of it, if for being
Yes,
honest.
yes. But what I mean is, so what and a failover cluster can trigger a failover if something wrong within SQL Server. If I have a VM and SQL Server stops running in that VM will not vMotion to another node.
No.
Yeah, so there's a big difference in how this reacts. Yeah, so VMware provides a much better solution to have the operating system running. I don't know if the OS crashes if it would move the VM, or if this is also a
There is automation for that. You can enable it. It's not on by default. If the
yeah,
OS essentially blue screens or goes brain dead, you
yeah,
can have it restart that VM. And it may be on the
yeah.
same host, it may be on a different host. So that is an option, but it's not one that I see most people enable.
Yeah. So on the physical thing where you do an FCI, a failover cluster, most servers have a blue screen detection. The physical hardware has blue screen detection, because you have to actually like tell an HP server in the BIOS which operating system you're running, so that it can actually check in a pretty clever way if this thing is running or not. Is there a case for false positives? Yes.
And that's
So
why
you might
most people
not.
don't turn that on in the
Yeah,
VM side.
yeah, and that's the same. Physical machines, it's pretty good. It's pretty good, but it might falsely detect, especially on very busy systems. If it relies on something happening in a certain frequency and you have a very busy system, that's also one of the drawbacks of failover clustering. If you have a system running at 101%, meaning it never goes below 100, the timeout between the two nodes, one node asking the other, hey, are you fine? The other one might not answer quickly enough, and this might trigger a failover. You can tweak these numbers very extreme so that this cannot happen by accident if you know it.
There's a
But
risk to that though.
there's a risk to that too. Yeah. So it's always like how easily when you have to like trigger that failover. Something a tiny little bit is wrong, let's fail over. Or you want to have like, yeah, it's really broken, and only if it's really broken. Everything else thing is. Also over the years, when I remember clustering on 6.5, the only option was anything went wrong, failover. That was the idea. Today, what clusters normally do is they restart the service locally a couple of times because normally that fixes the problem. I mean, we all know SQL, if you restart it, normally things go better. I know there's many exceptions to it, and corruption is one of them where it usually doesn't get better. But
Minor things.
usually if like SQL crashes or something, restarting the service normally fixes it. You don't need to actually fail over to the other node. Yeah, the failing over to the other node should be for cases where the node actually dies. Yeah, and not, hey, a query took too long, let's fail over. Um, I've seen people configure it for that, and not a good idea. Because backups take a long time, and technically they are a query, so backups might trigger failovers.
I think the most common one is what you just hit on, and that is that heartbeat detection mechanism not
Yeah.
responding in time. That could be due to a network issue. The system could be completely down.
Yeah.
Any number of reasons. The CPU could be at 100% and it just doesn't respond.
Yeah.
When there are a couple settings that you mentioned, same subnet threshold, cross subnet thresholds,
Yeah.
as well as a duration component for all of those that can be tweaked. But I would generally try to find a happy middle ground where you have some leeway and some flexibility,
Yeah.
and you're still going to get notified in a timely manner.
Yeah. And it also depends on how stable your network is. If you know that your switches will drop a package like every couple of seconds, these numbers have to go up.
Yep.
If you know that your network is like never fails because it's rock solid, these numbers can come down. Yeah. Yeah. That is also same subnet and not the same subnet. So that's a big topic. That's somewhere on the list, but since we mentioned it, it's a good point in time to get there. So failover clustering, you can have all the nodes in the same subnet, so they are connected by a layer 2 network, and that works fine. That was the original design of failover clustering. It was the only way to do it. And how it started at the beginning is that you had to have separate network cards, one network card for accessing the services on the cluster, and one network for the clusters to talk to each other, which in the original design was a crossover cable that was plugged into the network cards usually. By the way, each digital charged $2,500 for the cluster connection kit, which was a crossover cable. Uh, Good old times. Uh, they sold one to each company. After that, everybody ordered the like 50-cent crossover network cable in their local hardware
Is
store.
that because
Uh,
my 11-year-old could build one?
yes, yes. No, it was just it, and you think, hey, yeah, you need a cluster crossover connection kit, or if the network cards would be included in that, it would be fine. No, they were not. It was literally thing. Yeah? Don't ask me how much that freaking SCSI cable, that Y-shaped SCSI cable costed, where you had the thing in the middle. Um, we're digressing. So in the beginning, these two networks were separate, and each network could only do one of the two jobs. Then Microsoft had one of the most clever and stupid ideas at the same time, that you could use the access network as a backup for the heartbeat network, which technically is not a bad idea because getting that heartbeat network highly available was not easy. With two nodes that were right next to each other or a top maximum of 100 feet apart with the connection kit cable was easy. That thing was things. But once you started using 3, 4, 5 nodes, that you can't have cables plugged between all of them. So you needed some kind of network switch in the middle. And getting this thing highly available was practically impossible because you could only have one hub or something. And if that one failed, all nodes failed at the same time. So they came to the idea that you can use the access network as a backup. The problem with that is they did not think that through, how network routing actually works. So it was basically the moment you configured that the access network is the backup of the direct connection. Uh, all network traffic ran in circles. So basically, the request came, the outgoing was always going through the heartbeat cable, but the answer came through the access thing, which is great as long as you don't have any kind of like network security configured that checks that you can't have an answer unless you requested a packet. And that caused several million people to cry on this planet because someone with a very large ticketing sales platform had that problem. And during a launch of a very famous musician's tour, they had a network issue there, and the clusters couldn't like do what they were supposed to do, and nobody could buy concert tickets. So there were issues there. People got new jobs after that. Uh, it's so the network is thing is my recommendation these days is don't put a heartbeat network in there.
Yep.
Have your primary access network, have that handle everything. Again, when clusters were designed, 10 megabits was the average network size. 100 megabits were like, are you crazy? Are you like having too much money? Today, the minimum is 1 gigabit, and 1 gigabit can always squeeze in a heartbeat packet. Yeah, there's no chance on a 10 megabit network. You could easily saturate that network so much that you would not get a ping through. Yeah, on a gigabit network, good luck getting there. And honestly, today, 10, 25 gigabits are not an insane idea in a field, especially when you're talking about things. I would even say that gigabit and 10 gigabit switches are costing basically the same these days. Yeah, probably not in home scenarios, but in a data center enterprise range. I even didn't see much of a difference between 10 and 25 anymore.
There's very little at this
The
point.
cables, the network
The,
cables are more
the
expensive, the drop cables. But the actual the network cards cost basically the same. And the switch ports are like we're talking like $5 difference per
yeah,
port. Yeah.
yeah, it's
Um,
rare to find a difference right now. And just
yeah.
for the record, redundancy is one of those areas where if you're in a VM, it should be redundant under the hood. So one NIC for a virtual machine should already be resilient underneath, whereas in a physical server it might be a little more interesting.
Yeah. Now with physical machines, you still have usually what you do in a physical server, you have the two network cards in it. And each one goes to a different switch. And then you configure a team across the switches and your machine, and your network card has to understand that switch, and the switch has to understand your network card, and then they figure it out. And once this is configured correctly, you never have to think about it again till someone changes the configuration. Yeah.
Yeah, once those things are up and running, they just work.
Yeah. The problem is if it's not configured correctly, we have the same thing as before. Some combinations will work, some will not. The nice part is that one shows up very quickly. So
Yeah.
that one with basic tests, you can figure that one out. Yeah. But
Hopefully those tests are before you go live.
yes, that's what I mean. It's not something that network packets go through the network a couple of thousand times a second. So if anything on the network is wrong, it shows up very quickly. Yeah. But even then, it can be that it's great. And again, you have it on the primary server configured correctly, and the secondary, it's not configured correctly. So just because one machine now works doesn't mean that the other one works. So this is also a big plus that I see for VMware, that the VM is much simpler. It's one connection inside the VM that does everything you need, and the underlying magic of VMware takes care of the high availability. When you do physical machines with FCIs, it's up to you to configure everything in a good way. Good.
Yeah, there's also one other nice thing. If you're relying on the VMware solution, you don't have to deal with reading through the cluster validation report, which contains tons of things that you don't really need to pay attention to, and kind of hides the things you do.
Yeah, but the cluster validation report. So when you set up a cluster, there's a tool that validates the cluster. The problem is this thing checks everything without asking you up front what you actually want to do with the cluster. So if you're not using like 50% of the features of the cluster, you will get 50% errors in that report that this thing is not configured or is not working or is not doing anything. So for that report to be useful, you need a lot of experience, which errors actually count
Apply.
in your scenario and which not. The big problem is you have to run it. It doesn't matter if it works or not, because if you don't run it, the cluster will tell the Microsoft support engineer that you didn't run it and they don't have to help you.
Nope.
So you only have support for a cluster machine if you ran that thing is.
So
Uh,
when you run that tool, you save a copy of that report in case you have to call to Microsoft.
Well, so here's the thing. Technically, if you change, say you add a node to the cluster, you actually
yeah.
need to run it again.
Yep.
And
Any change.
honestly, you should check it. You should actually read through it, because there may be things in there that are going to be unexpected.
It's there for a reason. Use it.
Yeah.
It's free. It's
But
Yes,
included.
the
you
trick
just have
is,
too much knowledge. Go
if you
ahead.
really just want to mess with Microsoft, what I do is whenever I install a node, I run the validation. So I add the node to the cluster, and then I run the validation for that node only, which is good enough for the support. It doesn't mean if it works or not. It's just, if you have like a 16 node cluster, that report takes a day.
Yeah.
Yeah. If you run it for your local node only, it's done in a minute. So that's not something thing is, yeah. Should you run it for the whole thing? Yes. But if you just swap a node or something, just rerun it for that one node. Because that cluster report, if you're already in production, might actually like touch onto things that should not be touched while it's running. But it's important to have it. And you don't need that report, the actual HTML output that it creates, because it literally internally somewhere sets a flag that says that the check was run. And that's what they check.
I keep it as proof, and
Yeah.
that way you know that at the time you built it,
Yeah, it
it
was correct.
passed, and you can confirm with the system configuration that you haven't changed anything.
The problem why I have it never passes. It always passes to like 80, 90% because the other ones like it jabbers that there's no quorum device configured when I use a file share witness. Like,
Uh,
and if I use a quorum device, it jabbers that I'm not using a file share witness. Yeah. So
or NIC redundancy with what we just talked about. Yeah.
yeah.
or
So
even lack of shared disk. It'll
Yeah.
yell at you for that when you have no shared disk in your solution.
yeah.
Intentionally. Yeah.
Yeah, that's the problem with when you use it for availability groups, then the cluster testing thing, validation thing will always say you failed because of the shared disk problem. And with AGs, you don't have shared disk. What's the big advantages? Okay, so patching. So that's another one. Patching a VM is patching like any other single system that you have. And when you have that, you patch it, thing is, but during that patch, there's a likelihood that that machine will reboot or go down or the service stops. Definitely when you patch SQL Server, the service will go down and go back up. That's just by definition. On an FCI patching, that's a whole other thing. Because while you install that, you have to prevent it from failing over because when you stop and start it, that might actually trigger a failover when you have bad configuration. Also, you need to patch both sides sometimes and sometimes not. When it's an OS patch, it has to be applied on both sides. When it's a SQL patch, you only have to apply it on the one of them. Then it's on both. But it's one of the things where my never patch strategy works. Let me explain that. My
Yeah. I
never
was,
patch
thank you.
strategy is once you install this, when you install a system, you patch it up to the newest level. Like every patch needs to be installed, then you test it, then you go live. But the moment there's a new patch, what you do is you install a whole set of new machines, you patch them to the newest level, and then you migrate your databases on the new machine. You will very quickly have automation for migration because otherwise you spend all your life migrating. Secondly, all your clients will learn that migrations happen and that they have to deal with that. So they will use the DNS names you gave them and not the physical machine names to connect to the machine. So another very big advantage. But you also never have the problem that you have these half-run patches that you don't know the system in which state it is. Because when you run a SQL patch and it stops in the middle, and then at some point you reboot the machine and it comes up, would you still use that machine or not? Yep. So big question. And it's the thing is because the fun part is people always tell me, yeah, we patch every like once a month or something or once a quarter. And so like, yeah, okay, great. So there's a new version of SQL Server. No, we cannot install that. Because it's a new version. So, okay, why not? Yeah, I mean, we would need to install it on a new machine and then migrate because we don't do in-place upgrades. I'm like, you understand that patching is an in-place upgrade. Every patch is an in-place upgrade.
Yep.
It just the difference is it copies a little bit less number of files than a full version in-place
It
upgrade.
still
But
leaves a lot of clutter and adds up
yeah,
over time,
oh yeah,
and that creates bloat.
yeah. So the whole patching, and this is the thing is you need to be able to migrate your databases to new versions anyway, because nobody in production will do an in-place upgrade. That is just not something people do. So when you have that capability, you can also use it for patching. That's my don't patch strategy, but always be on the latest patch level. Will I ever find a company that is willing to do that? No. Uh,
I've got one,
yeah,
and they're a gem.
yeah, no, it's in theory and hopefully in practice it works great, but it's not a great thing. Yeah. Another thing is when you have external backup software, that needs some agent or so to run your backups. In the VMware solution, you install it. It doesn't matter where it moves the VM. It will just work. If you have a failover cluster, solution, you have to install that agent on both sides, or it needs to be a cluster-aware agent, which I've never seen. So you have to run it on both sides, and then you have to somehow teach the one that is on the passive node that it can't do backups. Because if that one starts to doing local backups, it creates errors, and then you get this famous error report every morning that half of your machines failed to do backups. And then your boss will breathe down your neck, and you are like, no, they're all done. It's just the passive machines, and we bought such crappy software that cannot figure out that it's not doing something. Um, yes. I just see in my notes one more thing, the layer 2, and we came here through the network. So the option was everything is in a layer 2 network. FCIs also allow you to be in a layer 3 network. So that means that the two nodes can be in different subnets, which is a requirement when you go from one data center to another, because you can't, no network engineer will give you a layer 2 connection between two data centers. That's just not happening.
I've got a couple. They've got layer 2 over layer 3 encapsulation so that they have the same subnets at both sites,
Yeah.
but a broadcast over here doesn't make it over here.
Yeah. So it's not layer 2. It's some magic.
That's my phrase right there. It's
Yeah.
magic. It works. It's
Yeah.
rare to find somebody to actually set that up right.
Yeah, no, and even if the two data centers are in the same city or so, nobody will like use a fiber just for doing that. Yeah. And it's good. And honestly, FCIs in two subnets work just fine. Yeah. The difference is if it's in on a layer 2 subnet, the IP address stays the same, and the cluster talks to the switch and changes the ARP, the address resolution protocol entry in the switch, and says it's now the other machine. This IP now belongs to that MAC address, and the failover is basically instantaneous. It's super fast, and that's fine. Yeah. If you have between two networks, so the IP address has to change. The time this takes depends on how long your DNS takes to teach all the machines, which is a little bit out of control of you as the administrator, because you can control by having a couple of beers with the sysadmin of the DNS server that it gives you like a time to live of a couple of seconds. You don't want to have it too short, because then you have a lot of unnecessary DNS traffic, but you don't want to have it in the, I think the default is like 30 seconds or a minute or so. You should get it down to like 10, 15, 20 seconds, which is fine, because that's also the time that SQL needs to fail over anyway, so you're not wasting a lot of time. But it has. So when you in a layer 3 network, the IP address changes. So you switch from your DNS name, switches from one IP address to another. And that works pretty fine, unless you put your DNS service behind a load balancer, then it stops working. But in all other cases, it works fine. But it takes extra time. And if your client is caching IP addresses for several hours, it doesn't work at all. So if you have a stupid client that thinks, hey, we can make things faster by not asking DNS servers all the time, this could be a thing. Is one thing that creeps up more and more is software-defined networks, SDNs, which is what clouds are using. Every cloud provider uses a software-defined network. They don't have an ARP protocol anywhere. So you cannot have a cluster in the same network on layer 2 in software-defined networks. When you do AWS, Azure or something, they have these little things that you have to put in front of your cluster that handles the network magic. And the reason for that is because they don't have the ARP protocol, so they cannot fail over an IP address from one machine to the other. It's just not possible in a software-defined network, because you would have to talk to their magic in the background that this IP address is now on the other machine, and they won't let you do that. So that doesn't work. The trick is that you put each machine in a different network and use layer 3 routing there. Then you don't need their software magic that they put in front of you, and they don't can charge you for that thing extra. And it works just fine. The annoying thing is that you need a different subnet for each node, even if they are in the same availability zone, which again they charge you for. It's just something. And why it creeping up? Because enterprises have started using software-defined networks in their data centers. And the same problem exists there. So there's no ARP, so you cannot fail over within the same subnet. That's just something. This is one of the things good to know because this is coming, and because in the end, let's say 10 years from now, every network will be software defined. There will be nobody's gonna do traditional networks anymore because the network engineers will not agree to doing it the old way.
Yeah, nobody wants to go program switch after switch after
Yeah.
switch with console cables
Yep.
in the middle of the night.
Yeah. Good. Yeah, so we're about halfway through. Of thing. No, we can stop at any time and do it in another one. And but as long as I see people connected, we keep going. This is gonna be one of these like 6 hour YouTube video. Nah, we'll keep it at like 2.5 hours or something. Yeah.
I will need a bio break at some point.
Yeah, just there's a cup. So the next topic that's on my list, we've gone through network maintenance, all that is done. Limits. Let me start with what an FCI. The limit is you can have 64 machines in a cluster. No, I've never seen a cluster that big. The largest one I've seen was 16 nodes, which is
Still
still,
big.
yeah,
Yeah.
still big, but was necessary for the task. Not for performance reasons, but for it was a gigantic availability group. Let's call it this what it is, and more than one availability group on the same cluster. Each node can have as many CPU cores as the physical hardware can do. Right now, the largest machine I've seen is 1536 CPU, 1536 CPUs. That's 28 cores per CPU times 32 CPUs, plus hyperthreading, plus whatever you can think of. I don't think that this number will go up anytime soon because nobody is building 32 socket machines anymore because two socket machines can now have like 384 or something cores. So that's plenty. And these cores are much faster than the 28 cores on the other end. So there's nothing is. Memory, you can go up to 48 terabytes right now. On the big machines with 32 sockets, you can usually go up somewhere between 6 and 8 terabytes on the smaller machines. And storage, it's 524 petabytes per database. That's a SQL limit.
And FYI, everybody, just because you can doesn't mean you should.
No. But the thing is, FCI basically has no limit than the actual hardware that you can buy.
Yeah.
There's the clustering doesn't stop you of doing something. Again, remember when you have 48 terabytes and you do a failover cluster, that has to checkpoint down to disk.
Yep.
So that will take 15, 20 minutes.
Takes a moment.
Yeah.
I mean, every
It's
time you boot up a physical server, it's got to check memory.
yeah.
So the cluster SQL Server does a similar process, right? It checkpoints everything. It runs through recovery and all of that stuff. That all takes time.
Yeah. Also, it takes a while to get your buffer pool full again when you have 48
Yep.
terabytes of memory. And this is one of the things SQL 2022 had like one of these features nobody cared about, except if you had that 48 terabyte beast. Because No, scanning the buffer pool for 30 pages was a single-threaded operation.
Yep.
And in 2022, it's now fully multi-threaded. So if you have 1500 cores, you can actually use all 1500s to figure out which of your memory is dirty and which one is not. But again, the 3 or 4 people that were actually affected by this, they were really happy about it. Everybody else, like, okay, because on a small machine, you couldn't measure the difference. But on a big machine, you could just shutting down SQL Server went from like half an hour to 5 seconds. So but I'm pretty sure I remember whenever I asked VMware admins to give me like large VMs, they had like issues with that. So I'm guessing there are some limits.
There's limits in VMware, I believe. If I'm current, it's 6 terabytes of RAM per VM. Maybe it's a little bit bigger these
Which
days.
is
I think,
plenty.
oh, it's definitely plenty for almost everything out there. I want to
Right.
say Hyper-V is a little bit higher, but not by much. It's still astronomically high for almost everything on the planet, though.
Right. CPU cores you can have.
I think 640.
So that went up. So when I started using this was all like 16 and 64 and something like this, and like half a terabyte of memory. So this is much better today. That's great.
It's a lot higher, a whole lot higher than it used to be.
But I
I
think storage, there's a limitations.
Yes, it is. In VMware, I did the math. It's like 3.2 petabytes, I believe.
Yeah.
And if you use the NVMe controller, I think you can go and add another 64 disks at some crazy big number. So I want to say it's still in the petabyte range per
Yeah.
VM, which is still more than
But that is you have
functionalities.
to work with like multiple disks and something like this.
Yeah, it's overriding a couple of defaults and being very strategic in virtual disk configuration and placement.
Because
But you
I
can do
noticed
it.
usually it was like whenever I talked to VMware admins, like the ones that use default settings or so, there was for a very long time like a 64 terabyte limit that a single disk they wouldn't give me larger than
60,
64 terabyte.
62. That's actually still a limit. Yeah.
Uh,
The virtual disk. Yeah,
yeah. So you need like hundreds of virtual disks and then you somehow concatenate them in the VM.
correct.
Okay. Yeah.
Yeah,
I
or
mean,
you can do in-guest or you can do raw device maps. I think you can get
yeah,
around some of that. But
yeah,
again, these ceilings are so high that
yeah,
odds that anybody's going to encounter that are going to be slim.
yeah. But it's something you have to consider. So the one of the few things where the FCI wins is if you need like super high speed thing is, and with the FCI you have no virtualization overhead. You get the raw speed that SQL would run, while on VMware you always have. It's not very big, but you have some overhead.
Yeah,
Yeah, it's it's
percent or two, sometimes lower, sometimes higher.
yeah, which always
Unless
also with each version gets better. Yeah,
Yeah,
uh, uh, that is all. You avoid the overhead unless you layer things on top of each other. So,
yeah,
which I generally don't recommend.
yeah,
yeah,
layering just compounds.
yeah. Good.
The complexity
So
should only be added where it makes sense, where there's a need for it.
yeah, no,
Can I put that on a t-shirt and mail that out to a bunch of my clients?
sure,
Yes, yes.
sure. The next thing is shared hardware. So we kind of always assumed, or when we were talking, then is on VMware you have multiple VMs on your VM cluster. That's the purpose. You have physical hardware and you break it up into smaller pieces. Yeah. You could have a gigantic VM that needs the whole host or so. That's out of the question. You can have that. But usually you want to, because today physical servers are so big that it's very rare that you have a single application that needs the whole server. SQL is one of the few exceptions that actually can get there. Yeah, so if you run your data warehouse, you don't want to have it on a tiny little VM. Yeah, that's normally not how it goes. But for many other things, I've seen SQL split up into like have 30, 60 VMs on a single host, and they were all happy. And thing is, and in development environments, I've seen 500 VMs on a single host, and they were still super happy. Yeah. Um,
It's
but
a similar thing to when you have mixed workloads. As long as you understand the characteristics of those workloads and you set policies in place to balance them, you're generally going to be fine.
Yeah,
yeah,
it's all in the operational management. I've got a couple places, they'll run a couple hundred VMs on a host. Everything's all perfectly fine. I've got others, they run one VM on a host and it crushes it.
Yeah.
yeah, no,
They also tend to believe that CPUs are magic, which, yeah.
yeah. But well, from a security point of view, each VM is completely separated from the other. Yes, there's some magic things that people were trying with hacking and stuff, like reading the memory of another process by looking at the temperature of something, uh, and things. But VMware does a pretty good job of separating the VMs from each other. Yeah. While when you have multiple instances of SQL Server on a cluster, if they are running on the same node, these processes can see each other. Yeah? So there's an easy way of one can influence the other. Yeah? On the
Easy is
FCI,
relative there, just for the record.
yeah. On the FCI, you have theoretical chance of controlling memory usage and CPU usage by affinitizing CPUs and so on. The problem is this gets super complex when you have to think about what happens if you move the instances from one node to the other, especially if you have an active environment where you have like 6 nodes in a cluster and 5 of them are running workload and the other one is like spare. Yeah. And it's designed that when something fails, they fail to the empty one. That's an easy scenario. But if you have like 4 machines running at 75%, and the idea is if one of them fails, the other machines take over the workload, then affinitizing CPUs or so is really hard. And thing is, it's fully dynamic, so you can have scripts that the moment the failover happens, you recalculate everything and everything's fine. But that's a lot of manual development work that nobody has done, and you can't download that from the internet, or no AI is generating that for you. Um, it's done. Memory you can control. You can tell SQL Server how much memory to use, which is more like a suggestion than an actual hard limit. So from my perspective, whenever I worked with, it was much clearer in a VM environment. I can tell a VM this is what you can use, and it's my choice if I overload the hosts or not. But if I don't overload them, they are not. I've done tests where I run one VM at 100%, and then I do a test on the other side, and then I stopped at 100% VM and run the test again, and there's no difference. They're not.
There are things though that you want to do on the VM side, because I agree with you. From a SQL standpoint, it simplifies things, but you want to make sure that when you've got SQL Server VMs, that you're setting proper reservations, especially around memory, CPU, anti-infinity rules. If you don't want 2 VMs running on the same node, um, just to kind of guide VMware a little bit so that it doesn't accidentally put you in a bad place, or worse yet, steal memory from your system when you need it via ballooning or something like that.
And if anybody watching this video has any questions on that topic, let me know. I have an 8.25 hour series on YouTube for free that will actually walk you and your system administrators through all of those pieces, because we could spend the whole rest of the day just talking about that. And I don't want to bore
Yeah.
everybody.
I mean, that's
So
probably worth a round table in itself.
Yep.
There's so many directions that we could go with that, and I would say they're out of the scope for today, but
Mhm.
that could actually be a future discussion. It's literally how to keep your SQL servers from abusing everything else around it.
Yeah.
Yeah.
On the FCI, all these controls are dynamic and I can run them while the stuff is running. So I can affinitize, de-affinitize, or change memory limits while SQL is running. VMware, is this dynamic or are we like requires a restart of the VM?
It should be dynamic. I believe it's dynamic. Correct me, David, if I'm wrong.
Sorry, I was getting the link to that. Can you repeat that question? I'm
Well, when
sorry.
we change reservation limits, it doesn't require VM restarts.
No, no, on the VM side, it does not.
Yeah. So if I have a VM that has like 64 gigs of memory and I want to change it to 128, this is a live.
It is, as of VMware 8.0, that is a live feature that is now NUMA aware. So
Mhm.
you can do that. In
And
earlier versions of VMware, it was supported but not NUMA aware. So small
Mhm.
VMs be fine, big VMs no. And
Yeah,
then older versions of VMware, that was not possible. But the
yeah.
stuff that you're running, the stuff that you should be running today, should be able to do that just fine.
Mhm. And the same for CPU cores or virtual cores.
As of 8.0, yes.
Yeah.
Prior to VMware 8.0,
Mhm.
you could add CPUs, but they were not
Yeah.
NUMA aware. So I told people to forget about it.
Yeah.
Yeah.
Anecdote on the side, on SQL, when you go back to SQL 2008 R2, you could add physical CPUs while the thing was running. Yep. It stopped working in SQL 2012. Uh,
I wonder why.
no, 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 no. The feature is still there. The feature is
Ah,
still there. The problem is no hardware. The hardware that was required to do that only supports SQL 2008 R2. SQL 2012 does not run
Yeah.
on this anymore.
Yep.
interesting.
Yep. So Windows has hot add and remove CPU. This is what VMware is using right now. The difference is back then there was actual hardware that could do that. So you could jam in additional CPU cores and you could remove it live. That was even stranger because you Windows could like unschedule them all
Oh,
and then say, okay, we are fine. Now you can pull it out.
I
Uh,
can see that being enormously complex.
we
yeah.
tested it. It was one of these things which again, awesome it's awesome when you do this in your lab, and then you make a decision, we will never do this in production.
Yeah, I was trying to think about the only machine that I know that you can hot add hardware like that today would be a Superdome X or a Superdome Flex, but even
Yeah,
those require a restart of the host in
yeah,
order to get the new hardware to be
yeah,
part of the
because
group.
Xeon CPUs can't do it.
Yep,
Itanium CPUs could do it. And
interesting.
so in Itanium CPUs, you could on the Itanium, the Superdomes, you could also change the memory while it was running. So you could add and remove memory while the machine was running, or replace memory sticks with bigger ones. Um, the only thing is that was literally a very bloody operation because a Superdome had 256 DIMM slots, and that's a lot of. So usually after like 50% of the machine, your thumbs start bleeding because it's not easy. But yep. No, this stuff all existed. The problem
Uh,
is nobody was willing to pay for that, so it
okay,
went
so
away.
Intel and AMD, hyperscalers out there want this, so make it.
It they have the circuits or whatever designed. They just haven't because the funny part is now all the new features that you see in like the AMD and Intel CPUs, they were already there in Itanium like 20 years ago. They were just not, it takes them forever to get them in over in a compatible way because why in Itanium was so successful in performance and not in monetary sales, but in what he could do was because they just threw away all the old crap. There was everything was designed ground up. It's like the same as what these ARM CPUs did. Yeah, the reason they are so much more powerful and efficient is because they don't have to deal with an A20 gate anymore that figures out if a memory access is the first megabyte or above the first megabyte. Yeah, this is insane. Every time you run your super high speed 64-bit Intel thingy, it does an A20 gate check.
You see
Because
what's on
some,
my desk over there?
yeah, I wish. So shared hardware, we went through that. Ha. So this is one. Um, I I I still over the years haven't come to an agreement. So again, back in the days, SQL 6.5, when you built a cluster, everything had to be identical. Yeah. If your two nodes had like 1 megabyte difference amount of memory, that whole thing would refuse to start and work. And yeah, everything had to be identical. The network cards need to be the same and the controller cards and everything. Yeah. These days, clusters really don't care. You can have an AMD box on one side, an Intel box on the other side. You can have a Broadcom NIC on one side and something else on the other side.
But you can only be one major version of Windows apart.
Yes,
Yep.
the OS is a different story, but from a hardware perspective, you can have different ones. Yeah. Um, so the question that I want to put in the room, do you think it's a good idea to have every node in a different hardware from a different vendor with different network cards, or you want to have all the same? Let me.
You're you're an evil man.
So what I would do is I do generally want them to be the same model
Mhm.
hardware, right? The configured same specs, but I also don't want them to be from the same lot, right? If there's
That's the thing.
something
Yeah.
wrong with that batch, um, that could bite me across
Mhm.
all the nodes.
Yeah.
So
Okay.
that's how I would do it different. Order
Mhm.
the first node month A, wait till
Yeah.
month B or C, order the second one,
Yeah.
um, something like that. But generally, I do want them configured to
Mhm.
be as close as possible.
Yeah.
Call me
So
weird. I would want that for my primary machines, but I would want one in there from a different vendor.
I'm
that's
okay with
that's
that.
exactly, yeah. Because the problem is if there's any driver or firmware
Right.
update, uh, that is so the reason is what I'm experimenting with is so what we talked before that you have the two network cards where you build a team that then goes out to two switches. Yeah. The problem is if they are the same make and model, they use the same driver.
Yep.
When you patch that driver for any reason, that driver needs an update, they both go offline at the same time.
Yep.
There's no way to only patch one. But if you have one Intel, one Broadcom network card, you have two different drivers and you can patch one. And once that's done, you can patch the other one. Yeah,
And if the driver has a bug, you
yeah,
insulate at least one path.
yeah.
Yeah.
So that's the thing. Makes it everything harder and thing is and try to convince your data center that you want one Dell machine in that cluster and the other one is an HP or something. They're gonna declare you insane. But
No, I use
instead,
one phrase,
yeah,
0 days.
yeah,
Right there. If they have half a neuron left in their brain,
yeah.
that one phrase is enough to justify that entire train of thought.
So with that statement, that also means that VMware has also no problem if one machine they don't have to be the nodes don't have to be identical. They can vary. They should be similar.
They should be
There's
similarly spec'd. The only thing that you would have a challenge with, it's less from a compatibility standpoint than literally just a CPU architecture perspective. So if you had an Intel chip and an AMD chip in the same
Mhm.
cluster, you can't vMotion between the two. You have to shut the VM down and then fire it up on the new host. Other
Yeah.
than that, you can run mixed environments pretty darn
Mhm.
easily.
Yeah. One thing that I'm um, planning on doing very soon is you can run SQL in Linux. And we are thinking about having, and this doesn't work with failover clusters or something, but it works with availability groups. I just want to mention it here. In that thing is the idea is to have a 3-node cluster. 2 of them are Windows that are the ones that usually run the whole thing, and 1 is going to be Linux.
Zero
Just
day.
in case there is some ransomware, something else, it cannot
CrowdStrike.
touch that machine. CrowdStrike, yes. They might have a Linux version of that thing soon. Just kidding.
No comment.
But it's the idea is that is one very different. I remember the days when I still had my ISP. We had a network operations center, which was basically a room for 2 people that were taking care of managing the whole network to be fine. And the way it was designed was one box was Windows, with Internet Explorer and all the Windows tools to manage everything. And the other box was, and this is how old this is, NetBSD, which is something very similar to Linux. And they use Netscape browser and things. So the idea was if we have any kind of virus attack, any kind of worm or something, one of the 2 will still be available to do something.
Yep.
Yeah, it was like there were different hardware vendors, different monitor vendors, different mouse vendors, different keyboards, as different as we could do. The only thing that was, if you physically would have blown up that room, they would have been both out. Yeah. But other than that, it was basically almost impossible with like a single attack to take them out both at the same time. Yeah. And that was the idea behind. And I always liked that concept, but again, then for a long time, clustering or so made it impossible because everything had to be identical. But it seems like the world is ready again for systems like this to make that. Having automatic failover in these environments, that's a different beast. But the idea to have one machine in there that somehow gives you a backdoor in, and backdoor is in quotes. It's not a hacking thing. It's just, yeah, one is still.
An alternate platform that is not subject to the same X as the
It is a
others.
system of last resort.
Yeah.
Yeah.
Dissimilar and disparate machine with similar levels of access.
Yeah.
Yeah, I I wish more places would explore SQL Server on Linux for that exact scenario.
Okay. So we have basically two topics left. You want to do the technical one or the financial one next?
What are the options?
Technical or finance? Cost or one more technical topic?
Let's do
Oh,
technical and end with finance.
Okay.
yeah.
The worst for last. Okay.
Exactly.
So, the technical thing that I've put in the notes is it a good idea to stack the 2 solutions on top of each other? So,
Oh.
Now, that said, I am going to play devil's advocate with that one. I would claim that if it's properly managed, you have, let's say, a 2-node FCI,
yeah,
and a host goes down. Okay, let's say it was the passive node. No big deal, life is good. But in the event that that happens and that machine is physical, you're now subject to vendor whatever getting you hardware. And it may not be the 4-hour SLA that you're paying for. It may take them a week to get you a main board or whatever.
yeah,
If it's properly managed, and that is in the biggest air quotes and asterisks you could possibly get, if a physical machine were to nosedive like that, and you've got spare hardware in the VM cluster, let's say the passive FCI comes up and running in a couple of minutes on another piece of hardware, and you're back into a resilient state.
yeah.
That is all prefaced on that entire architecture being managed properly by trained professionals.
So in that scenario where we're talking about an FCI that's running on ESXi hosts,
Mhm.
right? That is one thing. What I was freaking out about a moment there is something that both TG and I suffered with for a long time, and that
Uh,
was availability groups on top of FCIs with DAGs on top of that.
There's simply not enough of this to go around.
Yeah, because
And people think that's a prop.
like I can understand an FCI that exists with its nodes in VMware. In fact, I think that that's quite common
Yeah.
actually. Um,
And
generally
and
works okay.
you mean an AG with the nodes in there?
No,
Because
no, I've seen FCIs that
yeah,
live on ESXi hosts, and they're generally okay.
If
because
managed properly.
Yes.
the first big problem is there's very few people that know how to configure the disks correctly, because
Agreed.
Yeah.
shared disks on top of shared nothing shared
Yep.
nothing disks on top of shared disks is
It's a challenge. And it
it's a challenge.
like I prefaced with the biggest asterisks in the world, it
Yeah.
has to be done right. And there's not that many environments out there that
And
I find
the
that
other
get it
one
right.
is to teach VMware to not put the members of that cluster on that FCI clusters on the same host.
Yeah.
That's an
Anti-affinity
anti-affinity
rule.
rule. That's straightforward if the VM admins in operations are properly educated. And
Yeah.
if I have anything to do with it, they will be before that thing goes live.
Yeah.
But I'm not everywhere.
So,
What I have seen though that really doesn't work is not that scenario specifically. It's one I mentioned where you put an availability group on top of an FCI, because people think that when you do that, you can just turn on automatic failover at the AG level, and it doesn't work. You could turn that setting on. It's just not going to have an impact. So if that storage for that primary FCI has an issue, your whole AG's down.
Is
Yeah,
that
So
why people are
that's
doing that? Because I've seen that in a few places, and I've never understood why they chose to do an availability group with an FCI.
so
As
they
most
they
most of the time
operate.
I find people do that if they want to extend the availability for more like a DR architecture,
Yeah.
where they'll use the AG piece as asynchronous replication to another site. Do I recommend it? No, not at all.
No, they look at it as a shortcut.
Yeah.
Um, and then there are those that seem to think that this gives them better availability, but as TG, you did the math on this.
oh, yeah.
It's actually the opposite. You get
Yeah.
less availability. You have
Yeah.
less uptime.
So this is the same as with when you go with storage. It's like throughput and latency. Yeah. They don't scale in the same direction. Yeah. And so with an failover cluster instance, what you have is an outage. If you have an outage, that outage is shorter than if you don't have an FCI, because you have the failover and the other side takes over and it will most likely work. It will not protect you from all the cases, but you have way more of them. So instead of having one failure per year or something, you will have 3 or 4 failures per year where this thing fails over and you have a short outage. That might be okay for some businesses. Other businesses rather have like one outage per year for an extended period of time, but not have one every month. So this is the question: where is your business and what can the software you're running that uses SQL Server tolerate? Yeah. The other problem is, and this is what almost nobody considers when it comes to high availability, the chances of hardware actually failing these days is thing is when I started with clustering, one common failure in servers was that CPUs like fell out of the socket. That was a common thing because back then the CPU fans were still like mounted on top of the CPU, and this all was designed for machines to have the motherboard laying flat. But if you put it like upside down in a cabinet or something, they suddenly have a tendency to fall out because that yeah things that don't happen today. Yeah, we
Yeah.
we had memory chips like overheating and all. Today this is all taken care of. There's like 50 years of figuring it out. Hardware is pretty good. Does it fail? Yes, but not on a massive amount of times per day. Same with storage. Yeah. When I started, hard drives basically had a expiration date of 1 to 3 years. Nowadays, you can run a solid state disk for probably 10, 15 years and will not have an issue. Yeah. So what you're not thinking about is the moment you have shared disks that use a storage or network, your I/O bandwidth is very little. Yeah. Yes, you can have like 8 gigabytes per second, which sounds a lot. But once you get bigger, that's actually not that much. Yeah. So the much more common scenario for high availability is that you have to restore your database. And let's say you have a 100 terabyte database and you have a 1 gigabyte per second storage array, which is not that uncommon these days. Yeah, you pay already a lot for that. It will take you several hours to restore that database. Yeah. If you have a single physical box with a bunch of NVMe drives in it, you can restore that database in a couple of minutes
Yeah, in
versus
fact,
hours.
I have a timer right here for this. You can
Yeah.
see, there's your timer.
Yeah. Yeah. No, it's so, and if you take that into consideration, any service that uses shared disks will have lower high availability than the other one because the most common failure reason is that's where they actually are not that good at. Yeah. So that's a combination. On the other hand, you know that if you actually have a physical machine problem, you know it's gonna take you 3-4 hours to fix that because someone has to go there, pull it out, change things. Yeah. Anyways, yeah. So, and this is the part where availability groups just become the thing that you need to use. You need to have more than one copy of your data because that's for me the biggest issue with all these things that share something. Yeah. When you share your data, yeah, in an failover cluster, you have the data once. That's the thing that actually has the most value because I can always reinstall SQL Server. I cannot re-enter a petabyte of database. That will not happen. Yeah. So if I destroy the storage, that doesn't help me. And the same thing with VMware. If I have these machines where I can vMotion, they only have one copy of the data. There's not a copy of the data on each node. No, it's there once and it moves with the other one. Things. Are these storage arrays these days pretty good? Yes. Yeah.
They're not
Uh,
perfect, but they're pretty good.
yeah. But that's the exact same. They are not perfect. Yeah. And then the big thing is if one of these storage arrays fails, nobody has a plan how to recover from that. Yeah. You might have a DR data center and then you go live there. Hopefully you don't have any kind of replication between there because that might have destroyed the one on the other side too. But if a storage array actually because your spare capacity is probably on that array. If you reach a size where you have like 50 of these arrays in your data center, that's a different story. If one of them fails, the other 49 can probably take over the load if you figure out how to restore all that. Because these arrays usually now have multiple petabytes in size, or at least hundreds of terabytes. So restoring all the VMs or restoring all the databases that are on there will take a long time. So this is thing when you look at the whole life cycle of your whole thing, the overall availability might be better with just a single machine that sits there. The problem is that each individual outage will normally be much longer. But if you run in the big one, then you are thing is I remember this in Vienna when I still had my internet service provider. One of the competition was famous. They had for 5 years 100% uptime in their network. Their design was very simple. They had one switch. Everything was connected to that one switch. Yeah, the thing never failed, so they had no problem. Yeah, all the other ISPs had hundreds of devices that were talking to each other and rerouting and doing, and each one of these devices was, when something failed or they needed to reconfigure, there were always issues. Yeah, so we had hundreds of 10-second outages over the time. They had zero. Yeah, so everybody was going to them, but then that switch failed, and it took them 3 days to get it back up running, because they physically had to take it out and bring a new one in and plug in like 1,000 cables. Yeah, that physically takes a while. And so for 5 years they were up here. Then within 3 days they were at the bottom of the availability scale. Yeah? And that's the same thing with any kind of system that uses shared storage. As long as this thing works, it's great. If it stops working, then it's problem with databases on shared storage is if the database needs restore for no reason and fault of the storage array, it's the same problem. It will take forever. Yeah?
Yes.
So, and that's the list of what I thought about that we should talk about. That normally when you just talk about FCIs or something, nobody talks about. I hope we collected thing is. That leaves us with the last topic, which kind of had nothing to do with the other part, the cost.
But it has everything to do with everything.
Yeah.
Yeah.
This is the
Yeah.
part that gets your solution
So,
accepted or rejected.
yeah.
Yep.
So on the FCI side, you have to buy your hardware. So we can agree it's the same hardware on the VMware side. Your compute nodes, the hosts are the same. So we can assume them on both sides to be zero. There's no cost comparison. Yeah. On the FCI side, you have to buy for each and every node a Windows license, which is not that expensive. It's it's per core these days. Even Windows Server gets charged per core, but that's the least of a problem there. And then you have the license SQL Server in whichever the biggest physical node in your cluster is, that's the one you license. You are at least somehow clever and take software assurance so you don't have to license any of the other nodes. Because very careful, even with an FCI, where is one active, one passive, if you don't have software assurance, you have to license the other node. Yeah. So just for that, software assurance pays for itself.
Yep.
Yeah.
In
Not
droves.
yeah. And that's it. There's you access this thing and you are fine. There's no other cost. Um, if you run multiple instances on the same hardware, there's no cost difference. There's a limit. You can have only 25 clustered SQL instances on a cluster. And that limit is not based on how many SQL instances you can have on the machine, because when you cluster SQL Server, you need a drive letter that is exclusive for that SQL Server, and you need one for the operating system, and that leaves you with 25 that are not. And yes, you can use A and B as hard disk letters.
And I
It's
do.
very confusing for old people. Because these were the floppy drives in the good old days. But yes, you can run a SQL Server on A and B colon backslash something. Yeah, so that's the reason it's 25. If you have 25 virtual instances of SQL in a box, you already have a different problem.
Yes.
So that's not, but it doesn't change the cost. So it doesn't matter, thing is. So on a VMware cluster, that looks different. So the hardware is the same, but then you have to buy VMware, and I'm assuming they also charge per core or
So
something.
so you have two options there. You can license the individual VMs, right?
By vCPU, yeah.
By vCPU, which means hyperthreading doesn't count anymore. Or you can license the hosts themselves, and you license the entire host, and then you can put as many SQL Server VMs on there as you want.
Yeah, if you license the virtual CPU, you can do standard, you can do enterprise. If you license the host, you must do enterprise.
Yes.
And it is extremely recommended to buy software assurance for all of this.
So I buy the VMware, then I have to buy my Windows license for each VM
Or host cores.
or host core. So I can also do the same as with SQL. That,
Correct.
yeah, okay.
Correct.
Which probably, if you plan on using hyperthreading, it makes always sense to license the host, because if you license the host, you don't have to license the hyperthreads. If you not planning on licensing if you're not planning on using hyperthreading at all, then it makes sense to license the host when you oversubscribe your hosts. So you have 64 physical cores, but then you put like 120 virtual cores on it, because you know that your systems are never using all the capacity. You just want to have it when it's there. That is possible as well.
Yeah, and that makes financial sense right there. Do it at the host.
Yeah.
Therefore, you don't care. But if you are doing a VM per host, like a lot of us do with these big SQL servers, let's say you don't need all that capacity, it may make more sense to license the vCPUs for essentially a subset of the physical cores and buy software assurance, and then that license follows if you move the VM around.
Mhm. Yeah.
Yep.
You also have to be careful that what most companies then I worked with when we had SQL on VMs, that they built a separate cluster just for the SQL Server stuff.
Yeah.
And
You
then
don't want non-SQL Server workloads eating the CPU time for the CPUs you've paid so much money for.
yeah, and that makes sense. So thing is, doing the VM, buying the vCores licenses for SQL makes sense if you have one tiny SQL server that runs your phone system or something, and you put it on your regular VMware farm and you pay for that one guy.
Yeah, well, do the math on the finances. We've got a lot of organizations that we work with. They don't have the scale to necessitate a dedicated cluster and a bunch of physical machine licensing. They may have 2, 3 SQL servers. And in that scenario, licensed by the vCore, you can scale it, you can move them around, do what's financially best there.
But it's licensing is very complicated.
Yeah, you did a session for this group a couple of months back on, I would consider it an intermediate licensing session, and it was phenomenal. And if anybody here has not watched that, go back on YouTube and watch that, because that is gold.
Good. Yeah. So the last headline that I have in my cheat sheet is conclusion.
So conclusion is, this is your introduction to SQL Server FCIs in a VM environment.
I can condense that down to 2 words.
Yeah. So
it depends.
Yeah. So my summary would be, there's no clear winner. There's a case for both of them. It depends what you needed. For me, the biggest differentiator is that if I use the VM thing, it will not fail over if SQL Server has a problem. On the FCI side, if SQL Server has a problem, it will also trigger the failover, which can be a bad thing. Yeah, so it's not always. The thing is, from a maintenance perspective, VMware sounds much, much easier and more straightforward and less hassle. FCI, on both sides, you need to know what you're doing.
Yep.
If you're, none of this will work if you start setup and click next, next, next.
Yeah. And for everybody here, none of this will work if your organization does not have defined SLAs for these servers.
Yes.
That goes back to the 101 level, and that's a question that most people don't ask or have defined. You have to have recovery point, recovery time objectives defined for these database servers, or else the unwritten expectation from upper manglement is 0 data loss and immediate recoverability. But the closer you get to 0 on either of those, the more zeros you tack onto the price tag, and the more complexity you introduce into the architecture. And the more complexity you introduce, the bigger the blast radius is if there's a problem or if it's not configured properly. See the dichotomy in this? It's interesting.
Yeah. And the problem is often when you even on purpose or not on purpose, if you overpromise availability by either not specifying that it's way lower than everybody thinks or that the thing is, achieving high availability with luck is easy. I had years where we had 100% availability in the system. No, zero failure in all 365 and a quarter days. Yeah. Of the year. There was no outage, whatever. Could we guarantee that for any year? No. Yeah. It was just a year with pure luck. Yeah. Great year to get a bonus. But everybody was aware this could change in an instant and we could be down for things. Yeah. Our guaranteed availability in that company was 99.7.
I
Yeah,
think that's
because that
reasonable.
was what we could guarantee. Doesn't matter what fails, in 99.7% of the time we will be up and running, and the other 0.3% we will have things. And that for the whole year, if you divvy it out, that meant we could have had a case where we would not be there for almost a whole day. Yeah. And would that be a common scenario? No. Yeah. But there was a case, if this and this and this happens in this order, this is the problem we have. It would physically take that much time to move into a new data center and get it up and running in some hacked way. Yeah. But it's not it's something that most people fully underestimate. If you don't get, when you guarantee anything, then you have to be able to guarantee it. And things will go wrong and they will go wrong way worse than you think. Yeah. And the problem starts when you have more than one failure at a time. Always think what happens if this and this happens at the same time. You can define in your SLA that if more than one thing fails at the same time, all bets are off. Yeah. So if your network and your storage fails at the same time, okay, there's nothing I can do. But that's a data center failure basically that happens. Yeah. So you should have a DR site that can take care of that. So it's always possible to do something, but it's
Yeah,
not.
an example of this is a little over a year ago, I popped a tire on a pothole. Sounds okay. Until you realize it in the parking lot while I'm changing the tire, I noticed that 4 of the 5 wheel studs were bent. It meant that scrawny old me could hardly get the tire off and could barely get the spare tire on. That's multiple failures from one incident.
Yep.
Yeah.
And that's
And
why I should buy a 6x6 vehicle just in case.
that's why you should have a rocket ship.
Yeah,
Avoid streets
the
to begin with.
blast radius from these incidents are always a lot larger than they appear. And that's what I joke about being seasoned in IT. That's the biggest thing that it teaches you is the more experience you have with incidents, the more you realize that's never at first glance the one little thing that goes wrong.
Mhm.
There's always
And
cascading incidents and always
yeah,
odd scenarios that it's very difficult to plan for.
yeah, and make sure that nobody hangs pictures in your data center. It's the largest outage I've ever heard of. I wasn't there, but one of my coworkers explained it to me. He's a little bit older than I when that happened. Um, Downtown Chicago, there's a river that floats through downtown Chicago, and most basements in most of the skyscrapers are below the water level of the river. So having a data center, someone had the brilliant idea, we need to hang some picture on the wall and drill the hole in the wall.
No.
That created a 14-day outage in downtown Chicago for 10 or 12 skyscrapers. Because the skyscrapers are connected with each other. So just the water coming in one of them didn't help because
Because
it spread through all of them. And the problem was everybody who knows whenever you have a water thing like this, that hole gets bigger and bigger very
Yeah.
quickly. Yeah. So what happened is that this thing basically emptied the river into the data centers, and then the river brought more water, and
Wow.
Yeah, it took them a while to get a crew that
The
could
other
actually like repair a wall underwater, and it's not that easy. And then get the
the
water
other
out.
thing about that is the fact that those buildings often share resources with their neighbors. So like if one building produces a lot of steam, that steam will get sent over to other buildings near it, and they will use that so they don't have to produce steam, and it's just one thing fails, cascade.
But hey,
It's
it's consolidation prize. If that were to happen right now, at least the basements would be green.
yeah. People learn, don't put your data center in a basement.
Yeah.
It works great in your home test lab, but in a professional way, they should be above the local water line. Uh, Probably even consider like additional water coming in from any direction in high quantities, like Superstorm Sandy that wiped out a couple of data centers on the eastern seaboard for a while.
Yeah.
So it's like, yeah, but also if you put your data center in the mountains, an avalanche can like wipe you out. Yeah, there's no perfect place. Yeah, that's why you have more than one. And yeah. The only
Yes.
thing is, as someone said at the beginning, Ashburn, Virginia, the most famous town when it comes to data centers. Uh, and for everybody that does not know why that is, that's the only town anywhere on this planet that has a data center from every major cloud provider. So
Yep.
you can, if you have an AWS workload and an Azure workload and a Google Cloud workload and an IBM workload, and you have your local data center in an Equinox data center, they can all communicate with 0 milliseconds latency between each other. There's literally one intersection where they all meet and you can, its thing is, the problem is the cloud providers finally realized that, and usually any server there is about 25% more expensive than in any other data center. But it's great. And today it's public knowledge, but when we figured that out 10 years ago or so, the way we figured it out is the Department of Energy requires generators that are more than 15 megawatts to be registered, and that's public knowledge. And we found one town where all of them had a generator registered in their name. Uh,
Wow.
and that's why we
It's a
we
pretty
got
clear
really cheap
indicator.
co-location space down there back then. And today the company could actually make a profit by just selling the data center space. We needed a place where we needed we Office 365 SQL workload, which we had on-prem, and then a compute workload, which was in AWS. And we needed some place where they were like less than a millisecond apart.
Right
And
there.
this is things you don't think about, but even for something like this, if you want to have like an HADR between like two different providers, which is also an option if you're in cloud today, it's probably a good idea to have one node in one cloud environment and one node in another. That's the town to go to. The problem is if anything happens to that town, different issue, but that's again a DR problem. High availability, you want high availability between uh, Google and AWS or Azure and Google or something, that's a place where you can try to get that done. And it's doable. I'm just thinking like a 64 node cluster that is in a different thing everywhere, just for demo purposes.
A cluster with, are you saying a cluster with one node per cloud provider all in the same
Yeah,
town?
yeah,
Okay.
something like this.
That would be
And then
amazing.
That would be rather expensive because you're paying all those egress charges for your heartbeat.
Yeah,
yeah,
but that would be
this is only possible if
hilarious.
you get them to sponsor that thing.
Yeah.
Yeah. This is this could be like a marketing for all of them, but getting them all onto one table and discussing that, yeah, we need probably let's say 100 million YouTube subscribers for that channel. Then we can have that
Call
power.
Linus.
I'll get right on that. Yeah.
So please subscribe.
Exactly.
Yeah.
And with that, I think that's a great way to wrap this one up. Thank you,
Yeah.
TG. Thank you, Brandon. Thank you, everybody that stuck around for the last 2.5 hours. This was excellent. I know this is the first in the series, but I am confident this will not be the last in this series. So sign up for the Meetup group. Check out the YouTube piece. And do you guys have anything to add in there?
I have one more thing is one thing when I wrote up the concept for that is that the moment that video is uploaded, I will watch it again and then write everything down into a couple of pages and publish that somewhere as a PDF. We will probably put that in a comment or so where you
Yeah.
can find the PDF. But the idea is to have like to not just figure out the knowledge because I learned a lot today. Yeah, because
Yep.
things changed over time and thing is so I want to take the time and rewatch it and write everything down. I cannot promise how fast this is, but my goal would be like within a week or two after we have that should be possible for me to rewatch and write this down and generate this also as a in a readable format
Cool.
that
Send me
then
send me the PDF. I'm happy to host it and link it up here.
yeah.
Yeah, that'd
Cool.
be awesome. And
Yeah,
send me a link to it as well once it's hosted.
Yeah,
So I
yeah, no. This is
read
this
it.
is
definitely.
Because that's the thing, right?
yeah,
We all are smart people, but we all have stuff we can learn, and we all, I think,
yeah.
learned something today.
Well, it's how I
Yeah,
name a company. The only constant is change. And
yeah,
SQL Server is evolutionary in its change, but change
yeah,
is constant. And what worked 20 years ago didn't work 10 years ago. What worked
yeah,
10 years ago definitely doesn't work now. And what
yeah,
works today may not work tomorrow.
yeah.
So
No,
that's what
and
it's all about.
with every new version of SQL Server, something will change and best practices shift over time. Yeah, and yeah, and and I hope we do the next one. People that were listening and watching to this live or on the recording, post or comment with ideas for other topics.
Yes.
I think I provided a list of like 10 or
I have a
15 of
few.
these sessions already, but I'm happy to find people to talk about things that the audience actually wants to hear. So thing is
Yeah,
one
this
of the
is
very next ones is going to be to compare these kind of failover that we had today with availability groups.
yes.
The
Yep.
problem is why I didn't want to do all of them in one go. That would be a 10-hour video. Yeah.
Oh yeah, we'd be here until
I
midnight.
mean,
It'd be a great day,
honestly,
but our brains would be melted at the end of that.
honestly, you could do an entire pre-con or more just talking about the different flavors of availability groups and
Yeah.
how that impacts
Yeah. Yeah.
HADR.
So my idea was one, just have one first, the next one about availability groups,
Yep.
and then take this one and the availability group one and then compare them.
I love it.
And then
Yep.
actually come up with this is the scenario, and this is the best solution.
So
Ooh,
Yeah.
nice.
let's do this. Both of you email me when you have availability and let's go ahead and get it on the books for the next two because that will be phenomenal.
So I am on vacation most of April. So if you want to do something, yeah, I'll be technically in Europe. Part of that's at a metal festival,
That's
but I
cool.
don't mind taking several hours out of that
Yeah.
to
We'll do
do
this.
something like this.
Shoot me an email when it would
So
work for both of
I'm
you.
on vacation in April too,
Okay.
but I'm not in
Ah,
Europe, but I'm in the US.
It doesn't have to be tomorrow. It doesn't have to be next week.
oh,
Just when it's convenient for you guys, let me know and let's get this on the books because
you'll have an
this
email from me tonight.
awesome. And I will have for everybody here, if you are watching this on the YouTube channel and not live, do not hesitate. Reach out, comment on the YouTube video. We want to know the topics because this is fun and we're gonna do more of these. They're going to be kind of interspersed over the next 6 9 months. We're going to have fun with this. This is a fun topic. I love this conversational style of technical discussion. We're going to do more of this. And if there's a topic in this area that you want to go straight to the gurus here on the nuances and literally the above the 500 level, let us know because this is fun.
Mhm. So, final question. Do we want to reveal the name this time or next time?
Next time. Let's
Next time.
leave it hanging.
I just don't want to spoil the mystery, right? And maybe only reveal one word next time.
Yeah.
Yeah. I can give a hint. You need to be able to speak German to actually figure it out.
I'll get right on that as well.
Yeah. I'm still trying to learn Norwegian. German's next, but
I'm still trying to work on English. So. Awesome.
Guys,
And with that, thank you all for sticking around. And I definitely look forward to the next one. So let me kill the recording here if I can find my mouse.
Thank you, guys.